Hi, good afternoon. I think the whole idea of sustainability, when I left India about 38 years ago, we were one of the most sustainable country. Our resources were so limited, we didn't have any resource to waste. Whatever we used was reused and reused. What is happening now is, now we have so much resources coming because we have more money. With more money, we have more waste. And with more waste, we have more building types which are not properly designed because our taste is totally governed by what is desired by our clients, by our CMDs, CEOs, corporate headquarters. They like to see certain things certain ways, which these images, these icons, are established on a kind of pre-established mode. It's very hard for architect professionals for us to tell the client, no, you can't have this thing. And we're trying to find a common ground where we can take any building type and make it feasible and make it positive net zero. We make it sustainable. We don't have to deny. So this exercise, one I'm going to show you quickly, is basically that product because throughout the world, when you travel, when you go, you see office building type. Everywhere we all hate it. Whenever we see a large, big office building, we say, my God, what is this? What is this glass? What is all this? What I truly believe that all of us as professionals, as individuals, as homeowners, we can start a very grassroots sustainability, positive net zero process. We could take a small house, we could make it positive net zero. We could take a bigger plot, we could make it net zero. It is the desire, it is the knowledge. And I think the whole idea is as a public policy, which I'm not going to get into it, we were discussing early on, that we have to make our masses aware. And it is very interesting, my travels through Bihar, through other areas, I see small huts. They have these little solar panels. They charge my computer, they charge my cell phone. I'm going to a meeting and I'm just saying, my God, this is a different India. If we could use this very Gandhian way of understanding our resources, understanding our culture, we could change. So I'm going to turn quickly into images, going to walk you through quickly because Hariharan wants to have a more open forum. This is a headquarter building we're doing for a power company, like Christopher showed, Suzlon. Suzlon, more powerful company. They have much bigger land, 10 acres. They have whole wind farm. Our challenge here was a very small, in Gurgaon. It's about 4-acre property. And we took a challenge. How are we going to make this thing positive? What are we going to do to make it positive? How are we going to conserve resources? So from day one, this was an open competition. We participated, and it's been a slow process in a kind of a bureaucratic way, but we are moving ahead. Basically, we took the idea and we made it more of a neighborhood concept. See, the whole Gurgaon, even Delhi, we don't have public spaces. We don't have urban streets you could walk around. It's a constant chaos. The cars are all over you. You can't even walk in the streets. This is not the city I left, and it's just shocking to see what has happened. So what we tried to do, we took the property which was given to us. We said, no, we're going to make it a neighborhood center. We're going to make it a neighborhood campus. So basically, when we won the competition, the CMD of REC, Rural Electricity Corporation, he brought me here to Habitat Center. He took a walk with me. I said, why? He said, you captured my dream. This is my favorite building. I spend most of my time here. And you have proposed these art galleries, you proposed the cafes, and what you have proposed, I just love it. And he showed me these big frames and openings and this, and we were doing it totally from a very climatic point of view. We were not doing it as an icon, a visual part of it. So the whole idea started from a climate. We are in a Delhi NCR area. It's a very complex situation. We need summer to be protected, shaded. When it comes to winter, we need the same sun. How do you make a building which opens and closes? So what we did a very exercises about the bioclimatic building. How we make a bioclimatic building. So our basic understanding was, if we understand in depth the effects of climate condition to shape our building form, that will be our way to reach the goal. So we took the climate and we shape our building, and the whole building is shaped from that aspect. It is very open compared to our headquarters. If you look into the Lachian's litigious zone, you will see totally different type of building. So if you compare, to us, the democratic system, it is very open, it's transparent, it is light, it could be glass, it could be stone, as long as there's transparency is there. Not necessarily glass buildings are bad or they are unsustainable. There's a way to do them. And I think next we could also show you how we can do it on that part. So we just had a comparison that what can be achieved without sacrificing our culture here in India. The issue comes with, oh, glass is a Western product. No, it looks like that. My answer was, I was telling in our presentation that yes, we tried to make a glass which should look like silk or khadi. How could we make a glass? And we have been asking our glass producers here, what can we do with glass? So it should look like silk. It is a transparent material, it protects, it breathes, but it's a process which is going on, and we're going to share you how we're achieving it. So we compared with our post-independence, most headquarter buildings you see in Mandi House, around this thing, very solid, very tall building, courtyards, very close courtyards. Then we looked at very quickly, what are our sustainable strategies for this particular project, how we go about it. We're all aware, you are architects, engineers, you know all these issues, but I'm going to be pretty quick. We want to have open forum. So basically, we just have a strategy which is, we all aware like a passive design, orientation, sun studies, wind studies. So we did all these things, and this is how. We've taken a very typical courtyard. We made maximum exposure to the north and how these courtyards are open. Now, same courtyards. Instead of just today, with the structural systems, technologies we have, materials we have, knowledge we have, with all seismic issues, we can do things which will hold together, which will work, and give us a beautiful response to NCR's very complex dust, sun, winter conditions. Then we studied the whole options. The building is basically, on the passive side is, pretty clear. We all know north facing and, east. Only thing we tried to do in this project was, which was more unique, was we did extensive studies of climate with the help of TERI, with the help, because we could really model everything and we could really come to and understand and not have a preconceived shape. These shapes are evolved basically out of necessity and studying sun and responding it to those conditions. These are various south facade studies where we can see when to protect. The summer months, the building is complete in shade. If the building is in complete shade, we have a lot more options. I mean, this exactly shows March, June, what happens in the morning, what happens in the afternoon, how the buildings get shaded in the June months. Then other interesting thing we did with the computer modeling was we took the wind studies, which is the most unpredictable. And then when we're studying the wind studies, then we discover if we take the prevailing wind, if we lift our buildings up, it invites the breeze in. As the wind comes in with the narrow courtyards, we're creating a venturi effect. So the hot air is exhausting. The whole movement is happening. Now, these are modeling, these are studies, and we are looking into like a next level, next level of it. Then our other major key factor in this whole project was the solar pergola, which is about 9,500 square meter PV, this thing, which is part of the building system. It's giving us about 90-50 kilowatt of power. And you could see the shading effect of it. It gives us much shaded spaces. And then we have key landscaping features, which we are going with. Below the solar pergola, we have basically a suspended garden, which cools the whole environment. We have green wall louvers in this project and other standard proven technologies. Also, the two blocks, they're connected with bridges. And these bridges becomes your social interactive spaces you could go in and out. And it gives you green gardens and cools the whole building. Then the most critical issue today we are facing is we cannot ignore technology. Technology is changing. As India, any other country, we have to catch up at the global level what's going on, and then find our own local solutions. So we looked at the building envelope, we looked at the mechanical systems, indoor air quality, water, and electrical. In the building envelope, minute we have a well-insulated building with better than ECBC guidelines of the requirement with U values, we are trying to make it another 20% better. With those guidelines, with those set rules, we are getting a much better performance of the whole entire building. And we will share this thing on our website. We're going to share, as we build this building, where we're benefiting, what the issues are. Then each facade, whether it's a north facade, it responds to the north. And it is a direct response to the conditions on the north. With the time this thing, I'm just trying to move fast and give you the basic principles of how this building is designed. On the southeast, we have embedded louvers. We have a thicker glass, which is about 42 mm. We're getting a much better U values, and we are using embedded louvers. These louvers, at the vision light, you have a lot of clarity. You're getting a very good VLT. Above that, you have basically, it becomes a glass shelf. It brings lights in. It gives you more this thing. Our entire structure is made out of exposed white concrete with a slag, which is a blast furnace steel usable materials. We are reusing it. Then our west side is basically completely solid. We have some screens and stuff. And then we're using electrochromatic glass in areas which are public areas, which with the sun gets dark and light, and we could turn it as required. This building, as the office building, we need more flexibility with all the electrical and the wiring and all that stuff. So we have a raised floor, and we're using, it's basically a radiant cooling system. The whole slab has embedded pipes. It cools the slab, and your whole cooling system is controlled by that. This diagram will show you exactly how the cooling works. And also indoor quality, which is very critical, because most air-conditioned buildings, they don't have any. We are using 100% air conditioning. We're trying to get the fresh air, which we are cooling it, again, embedded louvers on the top, and dropping the cool air from there into the whole system. Every drop of water, we have 100% use of water. We re-harvesting every drop. The way it is done, it shows on the diagram how the water is all collected and recirculated. And the same thing on the lighting side. These are all LED. It just shows all what we are producing, and basically we're generating per annum 208 megawatt. And our annual use requirement is 189. So we have about 19. So, yeah, sure. Okay. Yeah.